In part C, we want to find out if the volume of snow is increasing or decreasing at t equals 4. We can figure that out based on if the rate of change of volume is positive or negative. The rate of change of volume. However, we kind of have two rates of change of volume. We have the rate of change of like the snow that's getting added, and we have the rate of change of the snow that is melting or being subtracted. So I kind of up at the top wrote that out. S of t is the rate of added volume. So if we tried to take the integral of that, that would be the volume that has been added. Over here, m of t is the rate of subtracted or melted volume. So if we take an integral on that, we would get volume. But really what we're trying to figure out is like which one of these is more effective at a certain time. Like, is there more snow that's getting added or more snow that is melting? What's going on there? So we need to compare them. And I focused on that over here on the left. S of t minus m of t is the rate of change of volume, like total. If you add some snow and you melt away some snow, you subtract the amount that you add and melt, you get how much snow is being either added or melted, like the net add or subtract. So if S of t is bigger, you get a positive number for S minus m, which would mean that more snow is getting added. And if m is bigger, that would mean that more snow is getting subtracted at a particular time, which means that the volume of snow would be decreasing. Okay, if we take the integral of this, we would get the total volume that is being added or subtracted at that point in time. Okay, let's give this guy a label. Let's call this A prime of t, because currently we have capital letters already. So if we try and take an integral to get a total volume at some point, we want to be able to say that that is just A of t is the total volume. Okay. So is the volume of snow increasing or decreasing at t equals 4? We're going to put the A prime of t equals S of t minus m of t, which is like your general form. We want to specifically know what t equals 4, so we got A prime of t equals S of 4. Oh, this should be a 4. That's how this is changing. A prime of 4 equals S of 4 minus m of 4. And we have our trusty calculator. Okay, we can do this a few different ways. We could type in like y1 of 4 minus y2 of 4. You could go into your y equals. You maybe have never done this before. I'm going to go down to y3. y3 is going to be my a prime equation. And that a prime equation is going to be, oh, I hit second, no. It's going to be y1 minus y2. Okay, so it just takes that function minus that function. Okay, we're plugging in 4, so I'm going to go to a table and take a look at what we get when we have a 4. Right, down, 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 and to the right, 11.8. Sweet. There's no numbers after it. Oh, yeah, there are 8.003, so 8.00. Beautiful. A prime of 4 equals 11.800. We can get a label. A prime is going to be yards cubed per hour. We know that because just subtracting 2 yards cubed per hour is going to get us the same label. We're not dividing or differentiating, you know, those things. This is a positive number if your rate is positive. Since A prime of 4 is positive, the volume of snow is increasing at t equals 4 hours. D, how much snow is left on the slope after 5 hours? So this is a volume. How much snow is on the slope after 5 hours? Okay, we are told that at t equals 0, the slope holds 50 cubic yards of snow. And at the very beginning, we put that means that A of 0 equals 50. Hey, look, I picked the right letter. I just used it again. Okay, so if A of T is the total volume at T equals 0 is still 50 cubic yards of snow. Okay. So it looks like we're going to take the integral of A prime, and that's going to get us A. Okay, integral of A prime of T dt is going to be equal A of, we know we're plugging in numbers, so this is going to be one of those fundamental theorem of calculus problems where we have A of something minus A of something. We're looking for A of 5, and we have A of 0, so I'm going to put the 5 first, 0 second, so that I can put 5 on top and 0 on the bottom. Now, you'll see a lot of calculus teachers who put this value on the left because you know the starting value. So they would put like A of 0 plus your integral equals A of 5. I like this way better, but you can totally choose. Let's plug this into our calculator. Okay, A prime is y3. I'm going to type in my math 9, go from 0 to 5 of y3 dx. Oh, I missed my 5. Looks good. And we get 45.335 equals A of 5 minus, and we were told that A of 0 is 50. Looks like we can add 50 to both sides. That would be, oh, way easier than I made it. 95.335 equals A of 5. And if A prime was yards cubed per hour, this is just going to be yards cubed. Does not tell us to justify, so we will not, because if we justify incorrectly, then we get points taken off, and nobody needs that. E, suppose the snow machine is turned off at time t equals 0. So what's going to be happening? There's no snow that's getting added, but of course snow is still getting subtracted, right? Snow is still melting. Right, but do not solve an equation that could be solved to find the time t equals k when the snow would all be melted. So we're looking for total volume equals 0. So it's like A of t equals 0, and we want to find t. So we're still going to have t for our time. Okay. The snow machine is turned off at t equals 10. So it looks like we are going to add snow from t equals 0 to t equals 10. So that will be like the integral of s of t. That will be our time frame to figure out the volume of snow that is added. Actually, let's do this. 0 is going to equal the volume added minus the volume melted. That makes sense? Okay, the volume added is going to be the integral from 0 to 10 of s of t dt minus the volume melted from 0 to k. It tells us k is when we stop. So we do not know that. And then this is m of t dt. Okay. So let's calculate this guy right here. So this is going to be math 9 from 0 to 10 of y1 math. Oh my goodness. Alpha trace enter dx, which is 228 over Oh, I wonder if that's the same as the answer key got. 228.619 minus 0 to k of m of t dt. I feel like this would totally work. The answer key goes from 10 to k, which is not exactly what this says. Let's do this a different way and see if we get the same thing. Or same type of thing. Okay, if we do 0 equals a prime of t dt's integral from 0 to 10 minus the integral of m of t from 10 to k dt. All right, so what I'm doing here is I've got the integral of the rate of the amount, right? So this is our a of t minus m of t business from 0 to 10. So we've got the snow adding and the snow melting for the first 10 hours. And then after the first 10 hours, we just have the snow that's melting. And that's going to all equal 0. This is probably a better way to do this problem than what I did first. So in this case, we would get this same integral, but instead of a y1, it's going to be y3. Oh, I did it again. Oh, and now it's graphing, so it's going to take forever. So proud of myself right here. Oh my gosh, it's going to graph all 3 of them. Wow. Basically what's going on, the difference that I made based off, compared to the difference that they made, was that we could split this up into subtracting the integral from 0 to 10 of m of t dt and the integral from 10 to k of m of t dt. I guess that's really what I'm looking for. And if I find out this integral, it should be the same mathematically, like this plus this should equal this number. Yeah, I got there. Alpha trace 3. This is like, good morning, Miss Campbell. 133.193. Minus 50 because we started with 50. I have to do this whole problem.